I'm going to use as an example the fourth hole at the Stanford University Golf Course. This is the Google Earth view of the hole on the left. It's about 160 yards, par 3. When the pin is tucked on the right corner of the green, as you see here, it's very close to a treacherous water hazard called San Francisco Creek. And the question is, where do you best aim your golf shot? And in the close-up of the green on the right, you could aim at the hole. Some people would advocate that. It's always better to be aggressive. You could aim at the fat part of the green that's farther away from the water hazard. You could aim short and left of the green, but then you've got a chip shot. There are a wide variety of choices there. Tom Weiskopf, in his book, would have said, be aggressive, go for the flag. He's a former touring professional. Jack Nicklaus would have a more nuanced view, and we can talk about that as we go. The important thing to realize about choosing an aim point is that you're not just aiming one shot at one point. In fact, wherever you aim, there is a shot dispersion pattern associated with that aim point that a golfer does not have control of, except to the extent that they can improve their skill level. As Stanford's coach Conrad Ray said to me recently, the secret sauce is the choice of aim point is more like aiming a shotgun than a rifle. Nowadays, I think most touring pros and many top amateurs, when they look at a hole and think about their next shot, they actually have in mind the whole shot dispersion pattern and picking an aim point with respect to aiming that shot dispersion pattern, the center of it, in the best possible place. But this is a concept, interesting, that most amateurs I know are not even aware of yet. It's all so new. The golf technology, based on Brody's book, is emerging extremely rapidly at this point. And these kinds of analyses are part of what can ultimately come out of it. So let's move on. I've just mentioned 3 possible aim points, but obviously the complete set of alternatives here is a continuum in 2 dimensions. You could aim at any of these blue circles, and the question is, what's the best one to aim at? Now, based on Mark Brody's book, and he analyzed more than 10 million shots that have been kept track of by the PGA Tour for every touring pro, every tournament, every shot, where it started, where it ended up, expected strokes to get to the target, and so forth. Data has been being collected since the early 2000s. That allows us to map every golf course in terms of the expected number of strokes to hole out for a given peer group from any location. So, for example, if the hole is right here on the right front of the green, if your ball is 8 feet from the pole, it turns out that good golfers make about half their 8-footers. They miss about half their 8-footers. 1.5 is the number of expected strokes to hole out from there. If you're farther away, like 32 feet, good golfers mostly 2-putt, but they 3-putt from there about as often as they 1-putt. So 2.0 is the expected strokes to hole out. The water hazard over here, 3.5, that's a bad place to be. The bunker is bad, but not as bad, and so forth. You can look at the various points. Every square yard here has an expected strokes to hole out number associated with it. I'm not going to go into further detail on that for this presentation, but for these purposes, I'm going to keep this map. I'm going to take this map as given. Now, how do we calculate the value of an aim point? Well, golfers are interested in making as low as possible their strokes on a hole. And the question is, when you hit your first shot from 160 yards away, let's say you aim it at this aim point right down here, front and left, but what you're really aiming is your shot dispersion pattern. And you could end up with any one of these shots within this pattern, even some outside this 95% confidence ellipse here. But if you want to quantify the value of the aim point, you simply look at the expected strokes to hole out for every one of these blue dot shot pattern points, and average across them. Now, this assumes risk-averse behavior, or I'm sorry, risk-neutral behavior, which is, of course, reasonable given that there are many hundreds of shots that take place over the course of a golf tournament. Anyway, for this particular location, the expected strokes to hole out from that point is 2.4. The question is, what's the best aim point in any of this area here that would cause that number to be lower? Indeed, if there is such an aim point that would cause it to be lower. So you say, well, how would I know anything about my shot pattern? Well, it turns out that shot pattern data is pretty readily available. When I was a kid growing up, I used to watch Gene Littler. He would go out to an empty athletic field and he would hit a lot of shots with a 6-iron or a lot of shots with a driver, and he actually go and try to learn something from his shot dispersion pattern. You can measure it directly. But again, within the last 5 years, there's a lot of technology available to help. In most anywhere in the golfing world, most metropolitan areas, you can go to a so-called top tracer range. And here, just a couple of months ago in Seattle, are some shots, 40 shots that I hit with a 9-iron. And it will come back and tell you exactly where did you hit each ball. And so you can calculate or estimate your own shot dispersion pattern from that. This is just a cell phone photograph of the TV monitor displayed there after I was done. There are also sensory recording devices where you can put sensors on your golf clubs. Your cell phone is connected to GPS. They can figure out how, the apps can figure out how far did you hit every shot. This whole area of golf technology is evolving extremely rapidly at this point. And then, of course, there's peer group data collection. The patterns I'm going to be using here are for touring pros or top amateurs like Division I college players, but we'll do sensitivities later to see how that would change depending on your assumption. So if we know some things about shot dispersion pattern. There are a lot of things that various shot dispersion that all shot dispersion patterns have in common. First of all, the farther away from you are, or the longer the shot is, the wider is the dispersion pattern. That's not surprising. But secondly, due to the physics of golf, there are certain facets that almost all shot dispersion patterns would reveal. One of them is that there's a correlation between hitting the ball left and hitting it too long. There's a correlation between hitting the ball short and hitting it right. That's because if you're a right-handed player, a shot to the right typically happens because your club face is open relative to its path at impact, and that adds loft to the club, which causes the ball to go shorter and spin to the right and stop more quickly. It's just the opposite for left. Typically, the club face is closed relative to the target line. It creates hook spin, which causes the ball to roll further, and also takes loft off the club to cause it to go further. So most any shot pattern for a right-handed player like that would look like something like this. It would be tilted. And for a left-handed player, it would just be the mirror image opposite. There's also an asymmetry involved, and that is that shots that are short, that there are many, many more ways as a golfer to hit a ball that ends up being short of the target than long. Rarely do you hit a shot that's so good that it goes 5 or 10 yards past the target. Usually it would just go a couple of yards past the target if you hit it really well, particularly off the fairway. But there are lots of ways you can hit a relatively poor shot that ends up being short of the hole. So there's a skewness here. A given distance significantly short is more likely than a given distance significantly long. So in whatever we do to capture shot dispersion patterns, we need to capture these particular characteristics.